So today we shall be looking at the length of an arc. So first of all, what is an arc? An arc is any portion of the circumference of a circle. An arc is any portion of the circumference of a circle that is bounded by two radii. So let's take for example, for an instance, we have a circle here, and the center of this circle happens to be here. So let's call this center O. So if this center O, and I have a line drawn from this center to somewhere on the circumference, I have another line from that same center to any part on the circumference. So let's call here A, and call here B. Now, having this, of course, these two lines meet at the center, so there must be an angle between these two lines, because an angle is formed whenever two or more lines meet at a point. So the line OA is the radius of the circle R, and the line OB is also the radius of the circle. So what we seek to get from here is just this arc, from this point here to this point here. This whole distance is what we refer to as the arc AB. How long is this arc? What is the length of this arc? So that is our focus. So with this information we are seeing here, we can now write that the length of the arc, length of the arc AB, let's say AB, length of the arc AB, I use that symbol for arc AB, is equals to, the formula is theta over 360, theta over 360 degrees times 2 pi r. Yes, and that's the formula. So, but in the case where it was not called AB, you can just call it L. Yes, L we use at times here to refer to as the length of the arc. So L is equals to, you can see write it as theta over 360 degrees times 2 pi r. So that's it. Now this distance AB is the length of the minor arc. As you can see, this portion is very small compared to the other side. So let me show us the major arc. Then if the one in red is the minor arc, then the distance from here, all this distance, everything going around this way, everything here now happens to be the major arc. So that's the major arc. As you can see, the one in blue is bigger than the one in red. The distance covered by the blue is bigger than that of the red. So this minor arc AB, the one in red, and major arc AB, the one in blue. So if the angle for minor is theta, then what should the angle of the major be? Of course, this is angle at the point. So to get this other angle here, we just simply do 360 is 360 degrees minus theta. Yes. So here we know the angle of the minor to be theta. That means the angle of the major should be 360 minus theta. If peradventure I know the angle of the major, yes, to get the angle of the minor, I will still do 360 minus the angle of the major. So it works vice versa. So let's see some questions here on how we can tackle them one after the other. So we have the first Okay, we have the questions here, the set of questions from number 1 to 5. From number 1 to 5. Number 1 to 5. So we will tackle them one after the other. Let's tackle them one after the other. Okay, so as for the first question, an arc of a cycle with radius and so on. So let's bring out the information we need there for this problem. Write out every information you need. So for number 1 here, an arc of a cycle with radius 14 cm. So my r here is equals to 14 centimeters. Subtends an angle of 135. My angle here, theta stands for the angle 135 degrees. Calculate the length of the arc. Calculate the length of the arc. The length of the arc we don't know. So the question is clear. It's clear. So length of the arc, we now know the formula. That the length of the arc, let's say L, is simply equals to theta over 360 times 2 pi r. Theta over 360 times 2 pi r. So plug in the what you have as your parameters in the formula. So my L becomes equals to, what is my theta here? Theta is 135 over 360 times 2 times, we are asked to take pi as 22 over 7. Take pi as 22 over 7. So I have 22 over 7 for my pi times my r is what? My r is 14. R is 14. I will have 14 here. So let's now solve. Let's call here over 1 and here over 1. So my L becomes equal to, I would have loved to cancel common factors, but some of us might get confused. So what I will do now, I'll multiply the numerator and then multiply the denominator and then divide. So I'll have 135 on the calculator times 2 times 22 times 14. 135 times 2 times 22 times 14 should give us 83160. All over 360 times 1 times 7 times 1 is 2520. So now press on the calculator. 83160 divided by 2520 is going to give us 33 centimeters. Yes, and that is the answer for this first question. And for number 2, the radius of a cycle. So it's there. So you can pause the video and copy the questions. So number 2, we now have the radius of a cycle is 28 centimeter. The radius of a cycle. So we know something there. R, the radius is 28 centimeters. What else do we know here again? And the length of an arc. Good. The length of the arc L is equal to 44 centimeter. The length of the arc. Now calculate the angle subtended at the center. Theta, we are asked to calculate. Theta, we don't know. So we are asked to take pi as 22 over 7. So take pi as 22 over 7. Anyway, you see pi, call it 22 over 7. So how can we solve this? Clearly enough, this question is talking about length of an arc. Yes, because radius is there, and we just heard something. We had length of an arc. So do yourself good by applying the formula for length of an arc, which states that length of arc L is equal to theta over 360 times 2 pi r. Please don't be confused. My L, check from our parameters. My L is what? My L, as you can see, L, we are told that L is 44. So you have to replace L here with 44 equals to theta is not given to us. We don't know theta over, but we have 360 there, times 2 times pi is 22 over 7 times, what's your r? What is the radius? This man here. This man here, we are told that it is 28. Yes, so 28. Good. So let's call here over 1 and over 1. So 44 is equal to, let's multiply the numbers first. So 2 times 22 times 28. 1232. 2 times 22 times 28. 1232. And then 1232 times theta should be 1. Sorry, should be 1232 theta. Then all over 360 times 1 times 7 times 1 is simply 2520. Okay, I can choose to do over 1 here, cross and then multiply. So that 1232 theta times 1 should give us 1232 theta. Then 2520 times 44. 2520 times 44 is giving us 110880. And so to get the value of theta, I must need to divide both sides by 1232. Dividing both sides by 1232. So 1232 we cancel out here. I will have theta equal to 110880 divided by 1232 is giving us 90. So the angle here, this angle in degrees, is 90 degrees. And that is the answer for the second question. That is the answer for the second question. Now to question 3. To question 3. 3 says the length of an arc of a circle is 90 cm. The length of an arc of a circle is 90 centimeters. Write down every information bit by bit. The angle subtended at the center is 240. That is theta is 240 degrees. Calculate the radius of the circle. We have to find r in this case. So, but we are not asked to take pi as anything. So, but let's take pi as 22 over 7. So, looking at this here, since you've read from the question line by line and you heard length of an arc, that means length of an arc should work in here. So, length of an arc L is equal to theta over 360 times 2 pi r. Always read the question to know what you are asked to find. mind the keyword. The keyword in this question I've heard is length of an arc. So your mind should strike at theta over 360 times 2 pi r. So my L here, length is 90. So I'll call it 90. So I'll write L is 90 equals to theta is what? Is theta here. Theta is given to us as 240. So I'll write theta as 240 over 360 times 2 times pi. You are not told what you take pi as, but pi is a famous constant. That is 22 over 7. So 22 over 7. And then times our r. R we don't know. This man here, we don't know what it is. We are asked to find it. So we don't know. So I'll put down R. So let's call here over 1 here. Over 1. So 90 is equals to 240. Multiply the numerator. 240 times 2. 240 times 2 times 22 will give us 10,560. And 10,560 times R should be 10,560 R. All over 360 times 1 times 7 times 1 is 2520. So let's call here over 1. I'll cross and multiply. So 10,560 R times 1 is 10,560 R equal to 2520 times 90 is 226,800. 226,800. And then what's next? To get my R, I will have to divide both sides by 10560 all over 10560. So 10560 will cancel out here. Our R becomes equals to 226,800 divided by 10560 is leaving us with 21.47727 and so on 27 in centimeters. We are not told what to approximate to, but let's take it as let's just approximate to one decimal place, preferably. You can choose to approximate to anything, but I think this is centimeter, so let's consider approximating to one decimal place, or at most two decimal places. So let's go for one decimal place. So the first decimal place here, this is my point, this is my point, and after this point, the first number or the first digit I'm seeing there is 4. What is next to this 4? It's 7. 7 is up to 5. Yes, I can take one from 7 and add to 4, so it becomes 5, and then my R becomes equals to, or becomes approximately 21.5 centimeters to, we just approximated now to one decimal place, and that is the answer for number 3. So let's look at the next question here, number 4. In the diagram, O is the center of the circle, comma, reflects XOY is 210, and the length of the minor arc is 5.5. So we're asked to calculate the length of the major arc. So how do we go about this question? um it's same process. So let's see this question now. Number 4. Now, bringing out the information here, we have in the diagram, O is the center of the circle, reflex X, O, Y. Okay. Now, the reflex angle here means the angle of the major arc. Yes, so that's my theta equal to 210. And the length of the minor arc, the length of the minor arc. So the minor arc, the length, let's call it L. You know, we are dealing with two arcs now, minor and major. So I need to differentiate them, like to specify by using L MIN. That's L for L, length of minor arc, which is equals to 5.5. Yes, 5.5 in meters. So we are asked to approximate to the nearest meter the length of the major arc. So we are asked to find the length of the major arc. Length of the major arc. So to find the length of the major arc, the formula is simply length of major arc. Length of major arc is equals to, I need to know the angle of the major arc. The angle of the major arc is the reflex angle. Yes, the reflex angle is the angle of the major arc, theta over 360 times 2 pi r. Yes, so if I'm to continue here, my theta is 210. I know my pi, we are not told what to take pi as, so let's take pi as 22 over 7. So we know, but we don't have r here. R is the problem. R is the problem we need here. Else we cannot proceed. Theta is 210. Yes, we know pi. Pi is 22 over 7, but we don't know r, and it's not in any way given in the question. Okay, but we have another fact. We have a fact of length of minor arc, and like I told you in the introduction, if I'm given the an angle of the major arc, to get the angle of the minor, I'll do 360 minus the angle of major. Also, if I'm given the angle of the minor and to find angle of major, I will still do 360 minus angle of the minor. So they work vice versa. So we are given the angle of the major arc, that is the reflex angle we are given. But to get the angle of the minor arc, I will do 360 degrees minus theta. Yes, all over 360. Yes, times 2 pi r. They share the same radius. So let's get the radius of the cycle from this minor arc, because the main thing to solve this problem, here, our what is holding us is just the length, the radius. So but we can get the radius from the length of the minor arc. So let's see how. What is the length of the minor arc? L sub min is 5.5. The length of the minor arc, as you can see here, is 5.5. So let's now write it down as 5.5. The length of the minor arc is 5.5 equals to 360 degrees minus theta is the angle of the big sector. I will have 210 degrees out of 360 times 2 times 22 over 7 times our r, we don't know r, so I will have now 5.5 is equals to So what is 360 minus 210? That should be 150. We have 150 here, all over 360 in degrees, then times 2 times 22 times r. This is over 7. Let's call here over 1 over 1. So we now have 5.5 equal to, multiply the numerator. So 150 times 2 times 2 times 22 is 6,600, and 6,600 times r should be 6,600 r. 360 times 1 times 7 times 1 is 2520. So let's call here over 1, cross and multiply. 6,600 r times 1 still gives us 6,600 r equals to 2520 times 5.5 is 13,860. 13,860. To get my r, I'll divide both sides by 6,600 divided by 6,600. So 6,600 we cancel out here. I will have r remaining. So 13,860 divided by 6,600. That's just 2.1. Yes, that's 2.1. 2.1 meters. Yes, so we've gotten our r as 2.1 meters. So I can now solve this length of major arc in red. I can now solve it. I say therefore the length of, let me shift a little. Therefore the length of the major arc is now equals to, we have here as theta. Theta is the angle of the measure, that is 210 over 360 times 2 is just a constant, times 22 over 7 pi, times my r is what has been found now as 2.1. So let's call here over 1 and over 1. So length of major is equal to 210 times 2 times 22 times 2.1 is 1,9404. All over 360 times 1 times 7 times 1 should give us 2520. So the length of the major arc is dividing 9404 by 2520, and we are getting 7.7. We're having 7.7 in meters here. We're having 7.7 in meters, but we have to approximate to the nearest meter. So the nearest meter is simply the nearest whole number. If there is 7 here, that is the whole number before the point. The number before the point is called the whole number. So what is next to this whole number is 7, and it's up to 5. So I can take 1 from 7 and add, and it becomes 8. So therefore our answer is approximately 8 meters to the nearest meter. So that is the answer for this question 4. So let's look at the last question that says an arc of a circle subtends an angle of 285 at the center. So we are just asked to determine the length of the minor arc. So let's write down the parameters we have here. An arc subtends an angle of 285. Okay, so um sorry, so for number 5, the angle we have here is 285, and we are given a diameter of 7 centimeters, and we are asked to calculate the length of the minor arc. The length of the minor arc. Okay, so now check this question. Let's not rush it. If you observe here, like I told you, 285 cannot be the length of the minor arc. No, two, I think the reflex angle, the angle, in short, all reflex angle in this case should be taken as the um angle of the major sector. Yes, all reflex angle should be taken as the angle of the major sector. So 285 cannot be the angle of the minor. So, and to do this, to get the angle, to get the length of the minor arc. So how then do we solve? Length of minor arc. All right, length of minor arc is equals to it meant it should have been theta over 360. Yes, theta over 360 times 2 pi r. Yes, but you agree with me here that I will not put 285 here in this theta, because this is the formula I'm setting for the minor arc. So we don't know the angle of the minor arc. We are not given. Yes, we are not given the angle of the minor arc. So this angle is way bigger. It's bigger. So it serves as the angle of the major arc. So to get the angle of the minor arc, I'll do 360 minus 285 to get the angle of the minor arc. So I will now write that length of the minor arc is equals to 360 minus theta. I'm not given the angle of the minor arc, but I'm given the angle of the major arc. So this is why I need to do this over 360 degrees, then times 2 pi r. So which is now equals to, I'll have 360 minus theta here, that is the angle of the major, is 285 all over 360 times 2 times pi is what? I'm not giving what to take pi as. Or let me see, let me check. Sorry, I just checked the question, the source. We are asked to take pi as 3.142. Yes, in this case, or this time around, we are asked to take pi as 3.142. So I just checked. So then I'll have to times my pi should become 3.142 times our r. If you watch clearly here, I'm not giving r. So, but like I told you, you can get r from diameter. You can get your radius from diameter. To get radius from diameter, you always divide the diameter by 2. Take for example, if the radius is 8 cm, to get, sorry, if the diameter is 8 cm, To get the radius divided by 2, you have 4 cm. If the diameter is 12 cm, to get the radius divided by 2, that is 6 cm. So to get the radius, whatsoever the diameter is, you divide by 2. And to get the diameter, whatsoever the radius is, you multiply by 2. To get the diameter, whatsoever the radius is, multiply by 2. So write it down. What I've just said now, put it somewhere in your book so you don't forget. To get diameter from radius, multiply by 2. That's multiply the radius by 2. And to get radius from diameter, that diameter, you divide it by 2. So in this case, our diameter is 7. 7. So, but to get the radius of this, that's 7. I'll divide it by 2, and I'll have 3.5. So the radius of this circle is 3.5. So we'll write 3.5 here. So this is now equals to, so we will have 360 minus 285 is giving us 75. Yes, 75. So as you can see now, this is the main angle of the minor. Yes, if you have two angles, in this kind of question, so the bigger angle will take the major arc, and the smaller angle will take, or we go for the minor arc. So 75 over 360 times 2 times 3.142 times 3.5. So let's call here over 1 and over 1 here. So equal to 75 times 2 times 3.142 times 3.5 is giving us 1649.55 all over 360 times 1 here is just 360, equal to 1649.55 divided by 360 is 4.58, and so on. So it's 4.582, and so on. That's a long decimal. So let's just approximate to one decimal place. So the first decimal place here is 4. It's 5. The first decimal place here is 5. So what is next to 5? Next to 5, we have 8. So I can take 1 from 8 and add to 5, so that it becomes 4.6 centimeters. Okay. To one decimal place. But from where I got this question, the OBJ is an OBJ question, so it has option. Option A is 4.58. Option B is 8.02 in centimeters. So option C is 16.04 centimeters. Option D 32.08 cm, and option E 34 cm. So the one that best suits is option A, 4.58 centimeters. Though in that case, they had to approximate to 2 decimal places. So if I were to solve this, my answer in 2 decimal places, I would have had it to be approximately 4. If it was to be in 2 decimal places, I will have that of course 4.582 in 2 decimal places. The first decimal place is 5, and the second decimal place is 8. What is next to 8? It is 2. It's now up to 5, so I cannot take 1 from that 2 and add. You only do that if it's up to 5 or more. So next to the second decimal place, the second decimal place is 8. Next to 8 is 2. It is not up to 5. So I can't take 1 and add to it to become 9. So no way. So our answer is 4.6 centimeters to one decimal place. Or going by the options, we can take our answer to be equals to 4.58 centimeters. So that's good. So anything and any approximation you do, since I'm not giving any instruction here, so like I said, I recommend you use one decimal place most times. So unless you are told what to do. So our answer is 4.58 centimeter if I'm to go with the options in the book. But if there were no options there, I would have just left it the way I did it initially as 4.6 to one decimal place. You're still very correct. Thank you.